So far, we've just been using the default mesh generator in COMSOL, and that's been sufficient. The mesh generator is pretty good. It's tailored to the different physics, and it works fairly well for routine problems. But we'll find as we continue that we'll want to have the option anyway to go in and adjust the mesh to make the problem solve better or maybe more stably, make various adjustments. And so here's the default mesh, and what I want to do is show you some things that you can do to tailor it. Basically what's happening is the solution is being, the governing equations are being discretized over this mesh. The finer the mesh, the higher resolution the answer. Also, the longer the solution takes to run. So we often will want to strike a balance between having a mesh that's fine and high resolution, but one that will run in a reasonable amount of time. In some cases, the stability of the analysis really is dependent on the mesh. And if the mesh is too coarse, the solution won't be stable and you won't be able to get a solution at all. And so there it's not just a question of how fast the model is and how smooth the answer is, how high resolution it is. It's a question of whether the model converges and you get an answer at all. Okay, so the first thing that we can do is go here and put in free triangular. This is a triangular mesh in 2D. And then if we right click and put in size, and this is now for the entire geometry, we can change the size here. We've got a couple of options. I guess the simplest one would be to use the predefined sizes and make it, if we make it finer, then we get more elements there. So we can also customize it, and these are various different options for customizing the mesh. This is a very simple mesh. The elements look all pretty much the same size, but in other cases we'll have places where the mesh is finer and where it grows, and this allows you to control the largest element, the smallest element, how rapidly the mesh grows from a small place to a large place. And I'll show you that in just a second when we have a place where there's a fine mesh. Well, let's go and put that in. So if we go up here to geometry, we've got this square. Let's put in another square, but this will be a small square, say 1/10 this size. Oops, that's not what I want. How about if we do this? Okay, so there's an area of interest, and so what I want to do is let's see what we get if we just use this default setting. Yeah, so there's the mesh. Looks pretty much like we had before, except you can see now this subdomain here is now, it's part of the mesh, and so the pattern looks a little bit different here where we have this square, but the mesh density is pretty much the same. But one thing we might want to do is have the mesh be finer right there in that square, because say that might be a place that we were particularly interested in. So what I'm going to do is I'm going to mesh the square first with this command essentially, and I'm going to do that by selecting the square. I'll hit my broom and brush all that stuff out and then select that one, and so I'm selecting this subdomain, and it's going to be a we'll just use for now, let's say extra fine. And now for this next command, I'm going to select domain and this domain, and it's going to be normal size. And so if I go and mesh that, I get this. So you can see the finer mesh here, and then what happens is this is a normal mesh out here, and so it's larger, and it has to grade the fine mesh to the coarse mesh. Okay, so that's what's going on there. That maybe that shows it a little bit better. One thing that we can see now is that if we go to, I guess we'll probably want to go to this one where we mesh this outer region, and if we go to custom, we can change the max element size, the min, but here's the maximum element growth rate. What this one does is control how rapidly it goes from this size to that size. So if I make this smaller, say 0.05, then we can see that it goes from this size out to this size over a much larger region. So the rate at which the mesh increases is much slower. And there's some reasons why we might want to do that if we have a place where we just want to we want to grade more slowly than what it does as defaults. Okay, so that's all pretty straightforward, I think. Let's get rid of these, and let's try putting in a quad mesh. So this is a quad mesh. It's four-sided polygons, and you can see that some of them are roughly square, but it's not completely square. Right here in the middle we have these kind of peculiar shapes, and this is done intentionally to remove a grain to the mesh. If the mesh is completely uniform grain, there can be numerical issues that result from that. So this quad mesh has some degree of randomness in it. So that's an option. I don't know. I generally don't use this kind of mesh, but it certainly is possible, and you might try it and see how well it works for you. Another mesh that is useful is a mapped mesh. I'm going to disable this quad, and I think what I'm going to do is, first of all, when we first look at this map mesh, I'm going to disable this little square. So we just have a square here, and the mapped mesh gives us something that looks like this. So this looks very much like a finite difference grid. It's just a regular orthogonal grid, at least in this implementation. It doesn't necessarily need to be, but this allows us to have a mesh that looks very much like what's done in finite differences. Okay, so those are the main kinds of meshes. This one here in boundary layers, this is really done more for fluid flow problems, and you may have noticed this one. This creates some fine meshes right along the boundary where you would have a wall, and that helps the convergence in some fluid flow problems. So you can experiment around with that. Okay, so let's take a look at controlling the mesh density in a little more detail. And one way that you can do that is by going here to More Operations and Edge. And I'm going to move this up. What happens is the mesh is generated in sequence. So these commands are done in sequence, and if you do them out of order, you can have problems, because once the mesh is generated, you can't generate it again with the same set of commands. Okay, so what I'm going to do is I'm going to specify the number of points that I want along that edge. And I'm going to do that by going to I select edge, and then I select here distribution. And so if I select that particular edge, now I can specify how many points along that edge I want. Let's say I want 50. Okay, I got to go here, and I've got to that was selecting a distribution. I have to also select it here up under edge. And so now I have 50 points along this line, and the mapped mesh projects it across like that. So that's useful, and I might also want to have a non-uniform distribution. So I might want to have more closely spaced mesh elements over here. And so what I'll do is use a arithmetic, or no, predefined, and I can use arithmetic or geometric. Let's try this, arithmetic, and we'll do 50 elements, and the element ratio, let's try 6. So what this does is it causes the elements to be closely spaced here and then increase as we go along this in this direction. But you can see that what happens is that it gets closely spaced and increases along this line, but not along this line because we've only specified the edge right along here. So what we'd want to do in this case is to also specify that edge and specify the distribution there. And now when we build it, we see that we have closely spaced elements here, and it grades in a uniform way. We can reverse the direction like so, or make it symmetric. Variety of options. And I guess we also have geometric, which is similar. Okay, so that gives you a good bit of flexibility. We could have this mapped mesh also with triangular elements, or we could have the edge distribution also with triangular elements if we go like that. So here are the edge distributions. And we would do this, for example, if we had something going on of interest right along the edge that we wanted to have a fine mesh in order to resolve. So let me also show you this place here. It's the mesh statistics, and if you open that up, it gives you information about the mesh. So this is the number of elements and the element quality here. This is important information because as you generate different meshes, you'll want to know how many elements you have, because that's going to dictate how long it'll take to run the model, and also the element quality. The element quality for a triangular mesh is going to be how flattened out the triangle is. These guys here that look like equilateral triangles, those will be the high mesh quality. And then places where the triangle gets flattened out, well, let's see, there's a little bit of a flattened out one. Those are lower mesh quality. The solution is less accurate in places where the mesh quality is less. This is probably just fine mesh quality. When you get down much lower than that in the, say, well, it'll depend on the problem, but this is something just to keep in mind as you generate different meshes. For simple geometries like this, it really won't be a problem, but if you start to have some real thin areas where the mesh has to become contorted in order to fit, then you could have some problems with the mesh quality. And if you're having difficulties getting the solution to converge, then checking the mesh quality would be a good thing to do, because that may be the problem. You may need to redesign the mesh. And one last thing, if you look here under messages, this shows you the number of elements that is in the mesh that you generate. So whenever we go and do this and build that mesh, it tells us the number of elements here. It also shows you a little green bar as the mesh is being generated. It's possible to make a mesh that is very dense and takes a long time to run. If we were to go to the advanced settings. Well, let's see. Well, this is just something you can do. Go here to size, and then if you go to maximum element size and you make this small, then the mesh gets finer and it takes longer to generate. And we can continue on down. This is 62,000 elements, and pretty soon it'll get to be longer than we have patience for. But yeah, it's working. So we can generate very fine meshes, and it takes a while to generate, and we want to kind of keep track of things as we do it. So let's just take a quick look at the statistics on that. So yeah, 165,000 elements, and we can see the average element quality is a little bit less. Um, but here's the distribution. Most of them are really quite good. All right, so um, try experimenting around with different meshes, particularly if you're having difficulties with getting the problem to converge, or if the appearance of the plots are kind of angular and not as smooth as you would like, then maybe you need to go with a finer mesh.